Hello and welcome. My name is Henry McNeese and I am the Incident Response and Forensic Analyst for the Canadian government. Today I will be presenting the Cyber Operations and Risk Management Briefing as it pertains to the Five Eyes Global Economic Summit being held in the United States. Briefing topics. The areas I will focus on today are software assurance, software development lifecycle, supply chain management, and recommendations based on analysis of the various SDLC methodologies. Software assurance. Why do we need it? As defined by the National Institute of Standards and Technology, NIST, software assurance is a level of confidence that software functions as intended and is free of vulnerabilities, either intentionally or unintentionally designed or inserted as part of the software throughout the lifecycle. In other words, there is a possibility that code will function in a way that it was not intended to. So, how do we achieve software assurance? First, address assurance early to avoid exponential cost growth. Software contains vulnerabilities. 84% of recorded software breaches exploit vulnerabilities at the application layer. 2. Make assurance and engineering focused throughout the lifecycle. 3 to 5% of defects are security vulnerabilities. 3. Collect evidence to support assurance claims. Level of confidence of free vulnerabilities requires proof. 4. Designate roles for software assurance responsibilities. Depending on the methodology, someone with another task can pick up this role. 5. Create and manage plans, reports, and artifacts. 6. Consider risk in all sources of software, whether commercial, libraries, code generation tools, and reusable code. 7. Budget for and select appropriate tools to identify and address vulnerabilities as the software changes. And 8. Determine effectiveness of software assurance activities. A software development lifecycle process comprises the different phases of developing software. The phases include planning the design, defining its software specifications, building, testing, and producing the final software product. All software employed in the Canadian Five Eyes Summit network follows the SDLC process before being given authorization to operate. The current software architecture design model used in developing secure software for the Canadian Five Eyes Summit is the waterfall design model. Other methodologies that the Canadian government will consider are the Agile model, Scrum, Rational Unified Process, also known as RUP, and RAPID. As mentioned in the previous slide, Canada employs the waterfall model. It's a model that's very structured. A step must be completed before starting another step. Goals determined early, suitable for small projects, and allows design changes early. The cons of this model is making changes is difficult, little involvement from the end user, and testing is delayed until the last steps. Because this model is not flexible and system testing is conducted towards the end, vulnerabilities found will dramatically set back the timeline as the process will probably get scaled back to the project's initial phase. The second one, the Agile model. This model encourages productivity and efficiency. It's flexible to change the project direction, and it's client-facing to incorporate feedback in the process. The cons of this model are potential for overlap between phases. Deliverables are not a requirement to progress to the following phase. The timeline is susceptible to change from the start. The Agile framework does not inherently include security in the SDLC. Agile is a rapid methodology for developing software. Consequently, its focus is not security. Processes must be implemented into the Agile SDLC to integrate security. The next one is Scrum. It produces a higher quality product. It's the most efficient, and it requires daily meetings. The cons of this is complex to implement and for developers to adopt. It works best with small teams and delays due to complexity. Secure Scrum processes can be implemented with security. The next one is the Rational and Unified Process. The pros for this one, documentation, risk management, and it reuses code. The cons, it's very complex process, hard to integrate, and too dependent on risk management. The software assurance portion of this is it's got minimal support for the development of secure systems. And the last one is the Rapid Application Development, RAD. This one, the pros, it's reusable components. It's user feedback during the initial phases, reduces costs, powerful tools to reduce time, progress is easily measured. The negatives on this one, it requires high skills needed to use the tools, absence of reusable components most likely leads to failure. The software assurance side, minimal planning in favor of rapid prototyping leads to a poor software assurance. Supply chain management. Supply chain management is the management of everything that involves an interaction of an application or plays a role in its development throughout the entire software development lifecycle. As it relates to security, it's the methodology of securing all components, activities, and practices involved in the creation and deployment of software. To secure the supply chain, one needs to assess the security and trustworthiness of the code that you consume, ensure developers are writing secure proprietary code, securely build and deploy code, harden data transfers methods used by applications, and continuously test and monitor deployed applications for threats. Recommendations. After an extensive analysis of the different SDLC methodologies, it is highly recommended that Canada implement the Agile model with the Secure Scrum process for security. Furthermore, it is recommended that the NIST 800-161 be adopted to manage the supply chain discussed in earlier slides.